Alright, hello again everybody. So the last thing we want to show you from this section is this example right here, which is determining whether a binomial is a factor. So we've been dealing with a lot of things that are factoring, and what we're building up to is looking at if something is a factor. If it is a factor, how can we use synthetic division to factor our polynomial? And so that's what we'll be hitting on a little bit next week, early next week, before we take our next quiz. But I just want to show you this process, which is kind of one of the starting processes to be able to do that. So what we're going to do is we're going to determine whether a binomial is a factor of a polynomial. And so what we want to do is we basically want to do synthetic division. And that's what this two steps talk about. And then we're hoping that we get a remainder of 0. If we have a remainder of 0, we know that in this, for example, in this first problem, the x minus 2 is a factor. Or in this one, the x plus 5 is a factor. Okay, so let's talk about basically what we got to do for this first example, and then we'll talk about in class tomorrow what we want to do for this example. So it's really straightforward. Remember the synthetic division process. We set this up like so. We also need to take this over here, the x minus 2, put it equal to 0 and solve, so we get x equals 2. That's what goes right there. We then take our coefficients here, looking to see if we need to put any placeholders in, which we don't because we have x squared, x to the first, x to the 0. So we just take our coefficients, put them down right there, and then remember synthetic division. The first thing we do is bring that 1 down, and then we go 2 times 1, which is 2, and we put it right there, and we add straight down and we get 0, and then we go 2 times 0, which is 0, and add straight down, and we get an answer of -4. So we've just completed our synthetic division process. What this tells us right here, since this is a number that is not 0, if it's not 0, not a factor. Okay, and probably a more formal way to say it, we would say x minus 2 is not a factor of x squared minus 2x minus 4. And if you think about this, whoops, ran off the screen. And if you think about this, what we're looking at right here is, can I factor this? Okay, so can I factor this right here into x plus something and x plus something? And the answer is going to be no, because there's nothing that I can get that multiplies to get -4 and also adds up to get -2. Okay, in particular, one of these answers will not be -2. Okay, so that's what this is saying. This is the process to figure that out. All right. If we were to happen to get a 0 there, then we would say that x minus 2 is a factor, and if we went ahead and factored this, one of our binomials down here, or maybe both of them, would be x minus 4, or excuse me, x minus 2. But it's not. Here's a shortcut way to do it, and so we can stop there and say